For today's video, we're going to try to analyze a scene of Fast and Furious 2 of 2003 and try to get if the scene can happen in real life or not. So let's go for it. Before doing any calculation, let's see some general information. We know the model of the car, that is a Chevrolet Camaro Genco. Its weight, that is 1,655 kilograms. For the weight that we're going to use in the calculations, it will be the weight of the car plus Brian plus Roman, and we also know the power of the car, the dimensions, and that it goes from 0 to 100 in 8.9 seconds. The first part of the scene that we are going to analyze is the beginning, when they have an initial velocity of 90 miles per hour and then achieve a final velocity of 120 miles per hour. Now, with that and the time that if we measure it is 6.43 seconds, we have enough information to get the displacement and the acceleration that they have in that period of time. If we use these formulas and we do the calculus, we get an acceleration of 2.02 meters per second square and a displacement of almost 300 meters. In the next part of the scene, we can see that the car enters to a ramp that we calculate that is approximately 15 degrees. Now, there we can calculate the coefficient of fraction and also the force apply on the car. But that's not very relevant to this analysis, so we will skip that part. In the next part, we can see that the car jumped from the ramp and then impact with the boat, and that's the part that we are going to focus on more right now. For instance, the thing that we are going to try to calculate is the displacement that the car have and the impact velocity with the boat. Now, the important part of the whole scene is this, when the car jumps from the ramp and impact with the boat. Now, we need to calculate the impact velocity of the car with the boat, and with that we can calculate the distance that they travel in that specific time. Now, for that first we have to get the impact velocity. We will use this formula of the kinetic and the potential energy of the conservation of mass. Now, for that we need the height. The first height of the initial velocity of the ramp, we calculate that is more or less of 1.5 meters. Now, the height of the boat, I didn't found in internet what's the actual height of that boat, so with a little bit of Photoshop we can see that the height is approximately 3 Camaros, that is like 3.9 meters. With that height, then we can substitute that and the values that we already know into the formula, and we get that the impact velocity is about 52.3 meters per second. With that impact velocity, now we can figure out what's the displacement that happened in that part of the scene. For that we will use this formula. And now, to calculate the distance, we have to make some changes. The acceleration won't be 2.02. It will be the acceleration of the Earth, and also the initial velocity we will have to make 52.77 sin 15, and with that we can have the displacement that happened. And if we do the calculus, we get a distance of 130 meters. Now, how can we confirm that? If we go over the scene, we can calculate with the cars the distance that it travel. So more or less approximately it will be about 6 Camaros, and that's a distance of 28.32 meters. After all this analysis, we can say that that scene is false, because the car achieves a distance of 130 meters and the boat is only about 28 meters from the ramp, and the boat won't arrive to the top of the boat, it will arrive to the bottom of the river. Now, we can change two things to make that scene happen in real life. The first thing can be the distance between the boat and the ramp. If we increase that distance to 130 meters, the car will arrive the top of the boat. Or the second option is to decrease the velocity of the car. If the car goes at a less velocity, it will travel a less amount of meters, and then if we calculate that specific velocity, the car will arrive to the top of the boat. And that's my analysis of the scenes. Thank you very much for listening.